Now we just talked about the dot product. The other kind of mathematical operation from multiplication perspective we might want to pursue is, instead of the dot product, what's called the cross product. Or the vector product. And just like the scalar product or dot product, the first one tells you something about notation. So the notation for the cross product is A times B, where you've got the cross in there. And the second one tells you what it produces. It produces a vector. So you put two vectors in, you get a vector out. Graphically, this one takes a little bit more thinking to get at. And part of the reason why it takes a little more thinking to get at is that it's a vector, so we need to think both about what the size of the vector is and about what the magnitude of the vector is. So graphically, if I've got the vector A and the vector B, here I again am going to think about what this angle is between the two, and I can figure out what the magnitude is of A cross B, or the cross product, fairly easily. It's simply magnitude of A times magnitude of B times the sine of theta instead of the cosine of theta. The direction of A cross B is a little trickier to figure out. It requires you to think about the right-hand rule. It's perpendicular to A and perpendicular to B and satisfies the right-hand rule. So what does that actually mean? Well, one way to think about it that I find handy is to imagine that I've got a screw, right? So here's the screw head. I've got the screw head lined up with the vector A, and I'm going to turn that screw into so that it lines up with the vector B. Okay, if I imagine doing that, I'm going to have to turn this right? Righty-tighty means the screw will go into the page. So if C vector is A cross B, in this case C vector will be into the page. There are a number of other ways to do this. You can line up your thumb with the direction of the first vector, your fingers with the direction of the second vector. So in this case, A points like this, B points like that, your palm points in the direction of the third vector, or your fingers, when they bend, point in the direction of the third vector. There are a bunch of options for this. The one thing I would encourage you to do is make sure you are actually using your right hand instead of your left hand when you calculate this type of thing. Okay, well that's how you do it, right? You can calculate what the magnitude is, and you can calculate the direction using the right-hand rule. What does it mean? Well, there are two bits of meaning to this. One is that it tells you how perpendicular are A and B, right? In the same way that the dot product tells you how parallel the vectors are, the cross product tells you how perpendicular the vectors are. But the other thing that it tells you is actually something about the plane in which the vectors A and B lie. So if you think about it, whenever you've got two vectors, they're going to be coplanar. And the cross product, if it's always perpendicular to those vectors, so if this, for example, is A cross B, then C is into the page, and that vector tells you about what the plane is. So if I imagine this is my plane, as I rotate the plane around, a vector that's perpendicular to the plane always tells me what the orientation of that plane is. So C tells me what the orientation is of the plane that A and B lie in. And that can actually be very handy in a number of cases. I think we'll talk about calculation of the cross product in the next clip, so this is where we'll stop this clip.